Hello once again and welcome to our lesson number 7. In this lesson we are not doing any programming. I just decided to address the issue of Siemens allowed addresses and data types. So this lecture, this presentation is mainly for Siemens addresses and data types. So it is mainly about addressing and data types. Okay, because I think it is critical for a programmer to actually understand how to address the IOs and also understand data types for those IOs. Okay. So before I waste your time, we're going to start this presentation. Let me just pick up my laser pointer there. As you can see on this first slide, if you can just have a look, I hope this slide is also clear. This a picture is clear. As you can see, we've got this logo relay, Siemens logo relay. I hope you guys are familiar with this PLC. You can see here we're just showing you the inputs, your two push buttons. Those are the inputs. Okay, those inputs must have addresses. The input address, say I1, I2 for this particular relay, or I0.0, I26.0, I45.0, I100.0, I100.7. You can actually put your own addresses and also update the hardware accordingly. Okay, that will only now be for those big controllers, say S700, S7400, S1500. Okay, but for this particular relay, but I just wanted us to understand that we've got inputs. Those inputs, they also need to be addressed. They need addresses so that the PLC actually understand which one is talking at any instance. Okay, I hope you guys are following that. Now, when the PLC now knows which one is on, which one is off, based on the addresses, it will now execute the program based on the states of those addresses and also update the outputs accordingly. But it also needs to know which addresses the program is written, and then which addresses must be actuated as on or off accordingly based on the program. Okay. Now also these addresses, the outputs, they also need to have addresses, the output addresses. Okay, so each and every output, it can be a relay, indicator lamp, or anything. It must also be given an address so that the PLC knows exactly which one must be turned on or off. Okay, and also for the inputs, it can be push buttons, it can be proxies, it can be sensors, it can be a level sensor, it can be an analog signal, it can be a digital signal. They also need to be addressed accordingly. And also you need to declare data type to say what data type is that particular address. Okay. All right, I hope you guys are following that. As you can see on this this picture here, we can just recap. The first one on slot number 1 is your power supply, the 3052 amp power supply. On slot number 2, we have that S7300 PLC, as you can see. Okay. And we have on slot number 4, we have that digital input card, a 16-bit digital input card. Say up to slot number 8, we have also a digital input card, 16-bit, 24 volts. VDC. Then from slot number 9, we have a digital output card, a 16-bit digital output card up to slot number 11. Okay, without any waste of time, you will want to actually wire. Let's look at, consider slot number 4. So at slot number 4, we have 2 bytes there. We have this first byte and this is our second byte. So this is your first byte, that is your second byte. So your default address at byte number 0. So this is byte number 0, that is byte number 1. Okay, remember, we have a bit which is on or off, true or false. Then we have a byte. A byte is made up of 8 bits. Okay. Then we have a word. A word is made up of how many bits? 16 bits. Made up of 2 bytes. Okay. So this digital input card is made up of 2 bytes. It's a 16-bit card. Okay. All right. Let's move on. Next slide. All right. So in this slide, we are going to be discussing the addresses and the mnemonics for those addresses. If that address is an input address or an output address, whether the byte is the bit or a byte or a word, is it what type of the data is that particular input or output signal? Is it a character? Is it date? Is it an integer? Is it real? Is it time of the day? Is it time? Is it a double word? Is it a double integer? So that talks to data type. Okay. So here also you have the description, data type, address range. All right. Let's do the first one. So the first one is your I. Your I denotes input. So this is for input. It's an input bit. Okay. Data type is bool. Bool talks to whether that input bit is true or is false. 1 or 0. Then the range is from 0 to 65535.7. Okay. As I've shown you in the first slide, that the first default address in that digital input card, it can be I0.0, such that the last input address will be I1.7, because that card was a 16-bit card. Okay. IB, this is an input byte. So if, say, I want to address the whole byte, it will be IB0. This is the first byte. Okay. Data type, it can be byte or character. This is the range. Okay. iWord, this is an input word. Input word, data type is word. It can be an integer. S5 time, date. That is your range for this particular signal. Okay. Remember, a word is made up of 2 bytes, which gives it 16 bits. Okay. ID is an input double word. It can be a double word, double integer, real, time of the day, time. This is the range. Okay, so if, say, I wanted to address a 32-bit card to check the status of a 32-bit card, I will use that address. I will say, I'll give it an address ID 0. This will talk to the whole 32-bit card. But if I want to address the whole 16-bit card, I will say is iWord 0. Then I will know that it comprises of iWord of byte 0 and byte 1. Are you following? I hope you guys are following. So we can now move on. If we look at ID 0, if I were to address the whole 32-bit card, it will be ID 0, which tells me that that address comprises of the first word, which is word 0, and word what? Talk to me. Because remember, word 0 comprises of byte 0 and byte 1. So the second word will be word 2 and 3, giving us ID 0. Okay, this is an input double word, which gives us, it can be a double word, double integer, real, time of the day, and time. Remember, an integer, it can be a number counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is an integer. It doesn't include fractions and commas. So looking at a real data type or real number, it will include fractions, 0.0, 1.0, 1.045, 3.045, something like that. That's a real number. This will now actually be looking at, say, the level of a tank. So there's a transmitter looking at the level of the tank. It gives us continuous values, real numbers. Okay. You can also convert integers to real numbers using tools in the TIA portal software. TOD is time of the day, data type. Then time, it can be S5 time, or say, like here you can see this address is S5 time for iWait. But when we talk about time, we're talking about IEC time. Okay. Q is for output bit. Remember, output bit is 1 or 0, true or false. It can be bold type, data type. This is the range also. Q for output, QB is an output byte, character, and byte. This is the range. Q word, again, is output word. Again, addresses, word, integer, S5 time, and date. QD is for output double word. Again, it's the same thing, double word, double integer, real, time of day, and time. This is the range. Okay, I hope you guys are following. Next slide. Memory. Let's say we have, in our program, we need to do some calculation. When we do that calculation, we want to save the product or a quotient or whatever, depending on what you are doing in your math function. Okay, so you want to save that sum or product, whatever, somewhere in the memory. Remember, this is just a calculation inside the software. It's not an input or an output. It's not a physical input or a physical output. It's just data that will be used in a program. So you can utilize the memory. The beauty of Siemens gives us an option to utilize a memory bit. Okay, let's take the first one. So the memory bit, which is this one, is a bool data type, whether it tells us is true or false. For this one, for the first one here, the memory bit, you can actually use it as a coil or as an input, doesn't matter. But let's use it as a coil to say, I want to actuate something inside the program, such that when this comparison to check if value A and value B are equal. If they are equal, then I want this bit to come on. So it just internal is inside the software. Okay. Also, there is also clock memory, which I'm going to talk about in the next lesson, which is lesson number 8. We'll address CPU properties. We'll talk a lot about clock memory. Okay. And the system clock of the PLC, so that you guys understand about the pulses and the frequency and so on. Okay, but looking at this memory bit here, again, is bold data type. Memory byte, MB is memory byte or character, the range, that is the range. Memory weight. So for instance, I want to save an integer value somewhere in the memory. I'll go, because I can see the range goes from 0 to 6555534. So I just want to save it at memory weight 100. So after I've done a certain calculation, I'm going to save it at memory weight 100. Okay. Then MD is for double weight. This is your memory double weight. The data type is double weight, double integer, real, time of the day, and time. This is the range also. Hope you guys are following. Okay, next slide. Peripheral IOs. What are these? Like I gave you the first example where I was talking about the level of the tank. So you are looking at the level of the tank using an analog transmitter. So it gives you a lot of values. So you want to wire that on an analog card, analog input card, but you still need to give it an address. We call those peripheral IOs. Okay. I'm just giving you a basic example. Okay. So if I want to address the whole, like I've said earlier, I want to address the whole, say, card. Looking at the first byte, I want to address the first byte of the 16-bit card. I'll go PIB. Okay, PIB, peripheral input byte. I'm only looking at the first, at that particular byte. It can be a byte or character. PI weight talks to peripheral input weight. It can be a weight integer, S5 time or date. PID talks to peripheral input double weight. This is the data type, as you can see. PQB talks to peripheral output byte. Okay. PQW talks to peripheral output weight. PQD talks to peripheral output double weight. This talks to raw values at the device, at the physical device, where the device is actually connected in the I/O module or output module. Okay, remember I is for input, Q is for outputs. Okay. I hope you guys understand and you are following. I will be also sharing this slide with you guys. Okay. Okay, let's move on. Timers and counters. Okay. We all understand, we know what are timers, what is a timer, what is a counter. So if you want to address a timer, say timer 0, timer 1, you will use T, and then description is a timer, data type is time, this is the range. Counter, again, counter 0, counter 1 is the counter, and then data type is counter. Logic blocks, okay. Logic blocks for S7 family. We've got FBs. FB for function block, data type is FB, this is the range. OB for organizational blocks, and then data type is OB. FC for functions, and then FC for data type is FC, this is the range. SFBs, these are system function blocks. Okay, these are system function blocks. They are given to us by Siemens. You can also write a program if you want from 0 to 65535. Again, these are SFBs. SFCs are system functions. Again, they are available. They are given to us by Siemens. You will want to know the difference between, say, between an FB and an FC. Okay, an FB is a function blocks that has memory, so it has a data block, an instance data block where values for this function block are stored. So the difference between the function and the function block is that a function block will come up with an instance data block, but a function doesn't come up with an instance data block. It's just a function to execute something, input then output, okay, but it doesn't store values in a data block. All right. Then OBs, like we've seen in our previous lectures or lessons, we were programming OB1. OB1 falls under OBs, organizational blocks. Is the main block that is cyclically executed by the CPU. We also have so many OBs. We also have OB100, which is very important to us, and OB101. Those are your startup blocks. I still need to make a lesson about those ones again. All right, I hope you guys are following. Okay, let's move on. This is the last slide. Data blocks. Okay, like I've indicated in the previous slide, like a function block comes with a data block. Okay, this data block is a memory area where values are stored for, say, a particular function block, or you can just create a data block in the Siemens environment or engineering tool. You create a data block, say DB0, DB1, DB2, DB3, DB4. Then you store those values for that particular program of yours, or for the values, the timer values, the level of the tank, the status of the inputs and outputs can be stored in the data block. The same data block can be exported, can be sent to managers as an Excel file if you want to do that. Okay. And then the data types can be DB, FB, SFB, or UDT. UDT is user-defined data type. Okay, looking at user-defined data type, which is the last data type we're going to discuss. The address is UDT, user-defined data type. Data type is UDT from 0 to 65535. I hope this was useful to you guys, and I hope you've enjoyed the lecture. Please like our videos and subscribe, and keep on educating yourself and equip yourself. You know, the competition is tough out there, and after lockdown, people will be looking for jobs. Make sure that you also upskilled and you can actually grab those opportunities, because they will be available as they were available even before the lockdown. But remember, you need to move with the speed. You need to move with the change. You must learn. You must educate yourself all the time. Okay. So God bless you and keep you safe. Stay indoors. Stay at home. Wash your hands. Don't touch your nose. Don't touch your mouth, like they're saying, and use available protective equipment. Okay. God bless you.